This would be order of operations. 2 times 5 is 10, plus 3 is 13. Now look, if I'm putting you to sleep right now, hang tight. It's going to get bumpy fast here, all right? So you all good with that? Let's try a negative number just to make sure. What's f, part B? What's f of negative 3? So that would be 2 times negative 3 plus 3, right? Order of operations again. Negative 6 first, plus 3 is negative 3. Most everyone is like completely okay with this, yes? Most of the time, yeah? Okay, let's keep going. I want to evaluate again. Same problem, all right? Same problem. Same function we're dealing with here. Let's evaluate, find f of t. So what am I telling you to do? Replace the x with t, right? Replace the x with t. So what would you get? 2t plus 3, and that's it. That's your answer. See, when I ask you to plug in a number, you got a number as an answer, right? Plug in a number, you got a number as an answer. When I ask you to plug in a letter, right, a variable, your answer is going to be a variable expression as well. That all right? How about this? F of negative 4t. So I want you to replace the x, right? This is the function right here, right? Replace this x, replace that x with negative 4t. So 2, I'm going to put in parentheses, times negative 4t plus 3. And you do your same order of operations. You multiply here, what would that be? Negative 8t, right? And then plus 3. All right. You doing all right? Okay, here we go. This is where things start to get weird. Okay, f of, how about, what do I want? Let's go t plus 3. What am I asking you to do here? What is this telling you to do? Replace x with t plus 3. Is this telling you to just put a t here and add a 3 on the outside? No. It's saying replace that x with t plus 3. So I'm going to write it like this. 2, replacing the x with t plus 3, and then plus 3, right? That's me replacing the x. I'm replacing this x right here, right? That right there is what's being plugged in. I replace that x, there it is right there, with the t plus 3. And that means you have to distribute that 2 through that parentheses now, right? Distribute this 2 through. You get 2t plus 6, and then you still had plus 3. So 2t plus 9. Yay or nay? Yay? No questions, you sure? Okay, how about this one? F of x plus h. Okay, put a star next to this one. This is going to be, f of x plus h is something you're going to see a ton in Cal 1. All right? F of x plus h. All right, so what does that mean? I'm going to replace what with what? X with x plus h. So that means in that formula over there, I'm going to replace the x with 2 things. So I'm going to put in parentheses, x plus h, and then plus 3. Distribute through, and you get 2x plus 2h plus 3. Can we combine anything there together? No. So that's our answer. All right. So I would say that this worked out pretty smooth because this was a pretty clean function, wasn't it? Let's try a more complicated function. So new problem. You want to do a quadratic? Let's do a quadratic, yeah. So let's say that we have, so this is a new example. Let f of x equal, let's go with x squared minus 4x minus 5. So I've just given you what we call a quadratic function, right? We'll get to that later. But this is a function. How do you know it's a function? How do you know that y is a function of x here? How do you know that? Because my notation, I wrote it down. I said f of x. So that's telling you that you don't need to think about it. It is a function of x, right? If you replace this with y, guaranteed that for every x, there's only one y that comes out, all right? So you know it's a function of x. You know that it's a function of x. And so now let me ask you some things here. Let's start simple. Well, I don't know if this is simple. I'm going to try and trick you right off the bat. What's f of negative 3? So that means you're going to replace all your x's, right, with negative 3. So aren't you supposed to take that negative 3 first and square it, right? So when I write that, I'm going to write negative 3 squared. Is it important that I have the parentheses around the negative 3? Absolutely, because there is a difference between these two. If you write these two things down, they give you two different answers. The one on the right is negative 3 times negative 3. That's 9. What does this really mean? Most students don't know this, but this is really what that means. When you have a negative in front of this 3, it really means a negative 1 times 3 squared. So if you do order of operations, you're supposed to do the exponents before the multiplication. So you do exponents, you get a 9, and then you multiply times negative 1, you get negative 9. So the answer to this is negative 9. So the question is, when we are here and we're supposed to square, right? We're supposed to square this x. Which one is it? Well, it's the one where it's in parentheses. It's whatever this is squared. And that's why you're going to wind up getting a positive 9 for this. Then I still have minus 4 times what? Negative 3. I'm going to put that in parentheses. And then minus 5. OK, so I've replaced all my x's with negative 3's. And I get, this is 9. What's this? Plus, right? Plus 12, because two negatives multiply to be positive. And then minus 5. And this is 16. Any questions there? No? OK, how about this? F of t minus 2. What am I supposed to do? Replace all my x's with t minus 2's, right? I'm replacing all my x's with t minus 2's. And when I say I'm referring to this formula, right? I'm referring to the function I was given. I replace that x with t minus 2 squared minus 4 times t minus 2 minus 5. Is that right to write it like that? No, that's a complete disaster I've just created, right? Because I'm supposed to square this, right? So that has to be in parentheses. And this negative 4 multiplies times that, so I need that in parentheses as well, right? Those are those algebra things that you can't mess up or it's all over. I have to square this, right? What does that mean? Just square each one? No. FOIL, right? That means over here on the side, I'm going to do this scratch work. I'm going to go t minus 2 times t minus 2. And I'm going to do this little expand FOIL, however you want to call it. I think, OK, so what you're trying to do is solve the equation, I think, right? Because we did that substitution when we were solving. So if we had to set this equal to 0, I would say, yes, do the substitution. But here, all we're trying to do is figure out what happens when we plug t minus 2 into the function. What new expression do we get? All right, so I'm doing that over there. I'm not showing the work. If I did that, I would get t squared minus 4t plus 4. That's what you would get if you expand this, all right? What do I still have next to it, though? Minus 4t and plus 8. That's distribution of the -4 through, and then I still have the -5 at the end. Everyone clear as to where everything came from there? What happens if you mess up one little thing here? It's all wrong. And what if you're in a calculus class and you mess it up? It's all wrong, right? So we have to, you want to get to, I understand, like, algebra is, it's a pain in the ass because you can't make any mistakes, right? I get that. But I promise you, the more you practice, the better you get at it. You'll make less mistakes, all right? But you have to practice. You have to keep going, doing more and more problems. Okay, now I'm going to collect like terms. Anything I can put together, I'm put together. So t squared, nothing there, right? Minus 8t, because I have a -4t, -4t, that's -8t. And then numbers, 12, what is it, 7? Plus 7? There we go.
Don't factor it.
No, you don't need to. You could, I mean, but we're not doing anything with that. We're just saying, you know, what.
Turn it into y, right? Like f of x is the same as y, so it's like the same as saying y is equal to t squared.
Yes, but we're saying y is equal to this. If you plug t minus 2 in, that's what you get. All right, you ready for the last one for this problem, part C, the big one? What's f of x plus h? F of x plus h, right? Put a star. That's the one that comes from calculus that we're going to need to be able to do. So I'm replacing my x's with x plus h, right? We're still using this function right here. So I do x plus h. I've got to square that. And then I've got to do -4, and then x plus h again in parentheses, and then -5. How do we do the x plus h squared? X plus h times x plus h, right? Expand, FOIL, right? I'm not going to show that step. It would give you x squared. Well, you know what? I will. I will, because you're going to be squaring x plus h a lot. So you may as well. We'll see it one time. So this is some scratch work on the side. I'm doing x plus h times x plus h. So my first multiplication, I get x squared. The second one, I get a plus xh. The middle one, I get a plus hx. And the last one, I get a plus h squared. And these two are the same thing because you can reverse the order. Because it's multiplication, it's called commutative, right? So you can flip it. So you actually have two of those. So that's why I'm going to have x squared plus 2xh plus h squared. That's this part. Then I distribute -4x minus 4h, and that's done -5 there. Can I put any of this together? No, there's no like terms there. So just leave it alone. That's your answer. Yes, I know it's ugly. That's your answer. We're going somewhere with this, all right? There's going to be a reason for all of this later. Just right now, it's hard to see the forest through the trees, all right? Because we're just trying to make sure we can do the mechanics here. All right, let's do something more complicated function, right? Here's one that I give in my calculus classes and students make mistakes on. Let's let f of x be 3x minus 2 over 2x plus 1. Oh man, this just causes complete nightmares in my calculus classes. If I asked you to plug a number into that, could you? You feel confident? Let me do one. Let's plug in -3 again. The good news is nothing's being squared here, right? So you don't have to worry about any squaring. It's just plug the number in. So we're going to go 3 times -3 minus 2 over 2 times -3 plus 1. All I'm doing there is just plugging the number in for x. On top, what do you get? What do you do first on top? In the numerator, what do you do first? 3 times this, right? That's multiplication. 3 times negative 3? Negative 9. Take away 2. Negative 11 on top. On the bottom, 2 times negative 3, negative 6, add 1, negative 5. That fraction does not reduce, but a negative divided by a negative is positive, so you get 11/5. Just leave it as a fraction. Okay, that's plugging a number, yeah? Okay, y'all ready to jump right into the fire? F of x plus h. F of x plus h. It's a different function. See, I'm giving you a different function. And so now I want to know what happens when you plug x plus h into that. I hate showing, I've told you this, I hate showing you the wrong thing, but let me show you what students do. That's wrong. This is what they'll do. They'll say that that's 3x minus 2 plus h over 2x plus 1 plus h. Do you see what that student did? They thought that x plus h plugged into this just meant throw an h on the top and the bottom. I don't know. I see that. I mean, that's what I see. I kind of get what they're doing here, but this is wrong, right? We are supposed to replace x, right? We're supposed to replace this x with x plus h and this x with x plus h. So it's going to be 3 parentheses x plus h minus 2 over 2 parentheses x plus h plus 1. Everybody see that x plus h being plugged in for x? All right, distribute through the top. 3x plus 3h minus 2 over 2x plus 2h plus 1. That's distributing through here. And there's nothing you can do there. Don't start trying to cancel x's and h's. You can't do that because there's addition and subtraction between the terms, right? So you're not allowed to do that. So that's our answer. All right, look at, let me zoom in here a little bit. Well, I don't know if I can zoom in anymore. Look at problems 43 through 50 there. You want to pick one? 45? 45. X over x squared plus 1. So we have f of x equals x over x squared plus 1. This is one of your homework problems. Why don't we try it? Why don't you try and do this entire problem? So part A, what's f of 0? Part B, what's f of 1? Part C, what's f of negative 1? Part D, what's negative f of x? Ooh, that'll be interesting. No, I got that wrong. Sorry. F of negative x. E, what's negative f of x? And then F, what's f of x plus 1? And then G, just a couple of problems here. G, what's f of 2x? And H, finally, the big one, what's f of x plus h? Okay, what time is it? It's 10 o'clock. Let's see how much you can get done in 10 minutes. All right, work together, help each other out, start doing these. There's a bunch of different problems, right? First plug in 0, get an answer. Then plug in 1, get an answer. Plug in negative 1. If you're confused on these two, this one just says replace x with negative x. This one says what? Just throw a negative in front of the whole function. That's it. Just put a negative in front of that. So just put a little negative there. You're done. That's all you have to do. And then these, just see what happens when you plug in x plus 1, plug in 2x, plug in x plus h. 10 minutes. Let's see what happens. I'm going to start putting the answers up here. How's it going, though? Do you all feel like you're making some progress? Okay. I'll explain D in a moment. All right, there they are. Yes. Oh, I missed one? F of x plus 1? Okay, well, I can tell you it would be this answer, right? X plus 1. This is x plus h, so if I replace h with 1, that's the answer. So you should get x plus 1 over x squared plus 2x plus 2.
Okay,
Yeah. All right, does anyone have any questions over those? Take a look at them. Some of the key things that I want to point out here, like on part C, when you're putting the negative 1 in there for x, it's in parentheses and it gets squared. That becomes positive 1. Same thing with this one. You're replacing x with negative x, and when you put it here, you have to square it. Why do I turn negative x, that quantity squared, into just x squared? Well, because this really means negative 1 times x, right? This right here really means negative 1 times x squared. And so I'm squaring each one. When I square negative 1, I get 1. And when I square x, I get x squared, which is why I write that down next. Am I allowed to do that? I thought I couldn't do that. I thought I couldn't do the 2 on each one. Yeah, when you multiply, you can do it on each one. But if it's addition or subtraction here, you can't, right? You have to actually FOIL it out. Can I clarify anything? You sure? Yes.
It's a small thing, but whatever you get, like, for example, I can see you have negative 1 over 2. Is it all right to say just put the negative in front of the whole negative 1/2?
Yeah, that's something about fractions that everyone should be comfortable with. When you have a fraction like negative 1 over 2, that's the same as putting 1 over negative 2, but that's the same as putting a negative in front of the fraction 1/2. All three of those are equivalent. So the negative can float. It can either be on the top or the bottom or out front.
Okay.
And you get to choose.
That's what I usually do. I just would-
Bring it out front. That's what we normally do later. We just bring the negative out front. So I can proceed? Are you sure? You have homework there, right? Problems 43 through 47. And look, you have parts A through H on each one of those. So that's a lot of stuff to do, but you know, do what you can. All right, now, the next thing we're going to talk about is the next concept we're going to talk about is, I'm trying to decide what I want to do here. I want to go straight to the difference quotient. I want to go straight to that. We'll come back to the other part. All right. So in calculus, there is this operation that you're going to need to be able to do to be successful in that class. And the first part of it, the first part of this thing you have to do in Cal 1, the first step for it is that you must be able to compute this thing called the difference quotient of a function. All right? So I'm going to put the definition up here first. Where is it? And right now, so I'm just showing you this because I want you to know this is in your book, all right? In your ebook. The difference quotient. And I don't see, y'all see a yardstick in here? No? Usually there's like a meter stick or yardstick on the, no? I need to get one. This is where I'd like slap the board and wake everyone up and make sure you hear me saying difference quotient. This is laser pointer, put in your eyes. No? Look, this is an extremely important concept. And we are not going to get into why, all right? We're not going to get into why we need to do this. We're just going to make sure we know how to do it. When you get to calculus, we'll explain why and where this comes from, and there will be a geometric meaning to this. Here, I'm just going to tell you what it is, all right? So difference quotient starts out with this. First, you have to be given some function, all right? Somebody has to give you a function. Once they give you a function, given a function, f, we can compute or calculate the following quotient. Quotient should, in your mind, quotient should mean fraction. We can compute this fraction, and it's right there. We can calculate f of x plus h minus f of x all over h. That is called the difference quotient. Again, if you want to know why, come to my office, I'll sit down, I'll show you the whole geometric interpretation of this and why we need it, right? Or I can point you to some of my Calculus 1 lecture videos. You can go watch that. We just need to be able to do this. And so this is like a generic formula. For any function someone gives me, I should be able to calculate this. So this thing does not depend on any particular function. It's a generic formula. So now what I'm going to do is I'm going to give you a function. I'm going to ask you to calculate this. All right? When you look at this thing, I want you to see that there's really only one part of this thing that's complicated. That. See? I'm already going to give you the function, right? If I give you the function, then you're going to know what that is, right? F of x is the function I give you. We're always going to divide by h. So that's nothing you have to even think about. The only thing that's hard is this part right here. Well, there's more hard after we have to clean it up, but the only difficult thing to plug in is this top left corner, all right? So let's do an example. So find the difference quotient. I'm going to abbreviate because I don't want to do this over and over. Difference quotient, I'm going to abbreviate that. Find the difference quotient for, let's start baby stuff. Okay, let's start with the, I think this was the first problem I gave us earlier. Might have been 2x minus 3, but let's just go 2x plus 3. Find the difference quotient. for 2x plus 3, the function 2x plus 3. All right, so I need to calculate this, right? And then once I do that, subtract that, and then I divide by h. So I'm going to first start with some scratch work. SW, scratch work. I'm going to first try and find out what is the f of x plus h. I'm trying to figure out what that part of the difference quotient is going to be for me here. Now, we already did this, didn't we? We know how to plug x plus h into this. 2 times x plus h plus 3. And then we distributed the 2 through, got 2x plus 2h plus 3. And there's nothing I can do to that, right? Like I can't put things together here? We're all right? No? Yes? You all right? Okay. All I have done is found out what this top left corner is, right? And it was pretty straightforward. So now I'm ready. I'm ready to do the difference quotient. So here we go. Scratch work is done.